Hello everyone. For this tutorial video, I'd like to explain how you can deduce the formula for the period of a spring or a similar oscillating system, as well as explain some of the technical vocab you will hear about it. In particular, you will hear a spring or any physical object that moves back and forth in a simple predictable manner, a simple harmonic oscillator, where harmonic has a more technical and obscure definition than harmony in music, and it means at a specific frequency, and this definition might make sense if you remember what harmonic series was in music production, as each entry is a harmonic, or something that follows a wave pattern. So now that we have given a special name / classification for this type of motion, we can deduce a period that will work for this type of system by first noticing that it repeats back and forth in the same way that the sine wave does from trigonometry. So we have a 2 pi factor because we are measuring a full rotation or full cycle in radians. And the other important factors are the mass of the system and the stiffness of the system, where the more mass, the longer the period because the more inertia it has. So the more difficult it is to move back and forth. And the stiffer the system, the shorter the period, because the more strongly it will restore it back to the equilibrium position. However, what makes this complicated is that the formula is not exactly 2 pi times mass over stiffness as you might expect, but instead is 2 pi times the square root of mass over stiffness. So we can use this information to deduce the period of a car shock absorber, for example. If we are told that a car's mass, including its load or the people inside it and other objects, is 900 kilograms, and the force constant of the shock absorber has a specific value of 6.53 times 10 to the 4th power newtons per meter, and we want to figure out the period and frequency of the vibrations. We would do this by entering in the stiffness and the mass as given in the beginning of the problem into the period formula, and then remembering even though a frequency formula was not given explicitly, we can deduce it as 1 over period, so we simply flip the numerator and denominators and the period formula. Once we plug in all of our numbers, we get the frequency is 1.36 Hz, and the period is 0.738 seconds. Know that we have deduced how the period and frequency work for a simple harmonic oscillator, as well as shown a problem that we can apply this type of formula for. We can talk about a specific type of oscillator, the pendulum, because this formula is different than the simple harmonic oscillator, although it is somewhat similar, as we will see when we deduce it in the next video. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.